All right, y'all go ahead and do the factoring and the math knowledge question for today. Pause the video, and then once everyone is finished, you can unpause the video, and I'll go over the correct answers. So for this factoring, you're going to take out the greatest common factor, which is x squared. And so you're going to have x squared plus 2 left over. X squared plus 2 will not factor any further, and so this would be your answer. For the math knowledge question, it asks what percent of the students are at least 16 years old? Well, those that are at least 16 fall into either the 16, 17, or 18-year bracket. So all you do is add up those percentages. 26% plus 31% plus 9% gives you a 66%. So E would be your answer there. Hey, we are looking at lesson 98 today. We're looking at the change of base, and then we're going to look at contrived log problems. Okay, so change of base and contrived log problems. Hopefully you'll understand those after this lesson. We are going to want to find the log base 5 of 15. So we're going to start by making this an equation. Log base 5 of 15 equals x. And then I want to put it into exponential form. So 15 equals 5 to the x. Now at this point, I am going to add a log to both sides because I want to get it out of exponential form. Okay? And then we can take this x, that's our exponent, and move it to the front. And so I have x times log of 5 on the right. And then to solve for x, I can actually divide by the log of 5. And so x equals the log of 15 over the log of 5. And so the way that we would plug that into our calculator is just to do the log of 15, close your parentheses, and then divide by the log of 5, and then close your parentheses. Because both of these have a base of 10, because it's understood there, and so we can use our calculator on that. And if you plug it in correctly, you should get 1.6826. And so that is what the value of log base 5 of 15 is. Now, there is a little shortcut. I'm going to let y'all think about it for a minute. But I know that the log base 5 of 15 is the same thing as the log of 15 over the log of 5. Can anyone see what I could do to quickly go from the left side to the right side? You can pause the video if you would like to think about it for a second. But here's what you would do. This 15 goes in the numerator, and then the 5 goes in the denominator. And so that is the shortcut, and that's the change of base. You go from a base of 5 into 2 logs with a base of 10. So let's look here. If we have log base 7 of 82, without doing all of that work, we can rewrite that as the log of 82 over the log of 7. And then we can just plug that into the calculator. And you should get 2.2646. And so that would be your answer there. Okay, so that's dealing with the change of base. Hopefully that makes a little bit of sense to you. You do not have to work out all of the steps like we did on this example, unless you just want to. If you forget the change of base and you can't do it this shortcut method, then you can certainly work it out. But you don't have to if you can remember it. Okay, so now we're going to look at contrived log problems. These are made up, and the reason that you practice these is so that you can get a better grasp of the properties of logs. Okay, and so these work the same for logs or for your LNs, your natural logs. But we're going to do these so that we can get some practice dealing with the properties of logs so that you really understand those, and whenever you actually need to use them in other problems, you can work them better. So there is a difference between the log of x squared and log of x squared. When you say them, you may say them the same, log of x squared, but there is actually a difference. The one on the left is saying x is getting squared, and then you take the log of that number. The one on the right is saying log of x, get that number, and then square it, okay? So those are two completely different things, even though they may kind of look the same. The parentheses are very important there. So what we are going to do is take this exponent and move it to the front. And so we have 2 log of x. We cannot do that with this exponent because it's not an exponent of the x. Log of x squared is saying log of x times log of x. Okay, so it's saying log of x times itself, not where you can actually move the 2 in front. And so we have log of x quantity squared on the right-hand side. So now what we want to do is actually to move the 2 log of x to the right side. So I'm going to have 0 equals the log of x squared minus 2 log of x. And from there, you're going to factor. If you notice, they both have an x squared in common. A log of x, They both have a log of x in common. And so I can pull out a log of x, and I'm left with a log of x minus 2. So again, they both have a log of x in common. Log of x squared is log of x times log of x, which is what I have right here, log of x times log of x. And then if you look here, you have a log in that minus 2 log x, so you pull it out, and that's what you are left with. Now that we have it factored, you can set your factors equal to 0. So log of x equals 0, or log of x minus 2 equals 0. Over here, the base is 10, so I can make that x equals 10 to the 0, which means that x actually equals 1. So that would be one of my answers. On this one, I can make it log of x equals 2. The base is again 10, so x would equal 10 to the 2. Well, 10 squared is 100. And so my two answers are 1 and 100. Okay? So that is one type of contrived log problem. Let's look at another contrived log problem. We've got the log of the square root of x and the square root of log of x. So again, those are two different things. One is taking the square root of the x, and one is taking the square root of the log of x. So the first thing we want to do is to write them as fractional exponents instead of with the radicals. Now on the left side, we can take this 1/2 and move it to the front. So we would have 1/2 log of x equals log of x to the 1/2. Now at this point, what you're going to want to do is to set everything equal to 0. Well, before we do that, you want to more than likely make the right-hand side just a log of x instead of log to the 1/2. And so we can square both sides to get rid of that 1/2. So 1/2 squared right here would be 1/4. And then we would have log of x, all of that squared. And then log of x to the 1/2 squared, those go away, and you're just left with log of x. And so now we have a log of x squared and a log of x, kind of like an x squared and an x. And we're going to want to move everything to the left side so that we can factor it. So now they both have a log of x in common. And if you pull out a log of x, you're left with 1/4 log of x minus 1. And so we can set our factors equal to 0. So log of x equals 0, or 1/4 log of x minus 1 equals 0. This 1 on the left, the base is a 10, so we have 10 to the 0, which means that x equals 1. Okay? On the right-hand side, we would have 1/4 log of x equals 1 to multiply by 4, and I have log of x equals 4. My base is a 10, so x would be 10 to the 4th, which would be 10,000. And so those would be your two answers, 1 and 10,000. Okay. Let's look at another one. We have the log of x equals 3. So on this, what you want to do first is to ignore this outside log. And we're going to look at what is the log of x equals 3. Well, this is a base 10. So that means that x equals 10 to the third. So x equals 1,000. Okay? Do y'all see that? Log base 10 of x equals 3. And so x equals 10,000. Now, from there, we have to deal with this log. I'm sorry. We wanted to cancel this one out and make it an x. So log of x equals 3. And so that blue x there equals 1,000. Okay? So now we know that the log of x, we set equal to x, which was 1,000. And so then your base would be a 10 here. And so x equals 10 to the 1,000. Which, if you plug in your calculator, I'm pretty sure it's going to give you overflow method or overflow error. So you would just leave it as 10 to the 1,000. So let me go back over that one again real quick. We're going to make this disappear. And so I'm going to make it an a this time. So the log of a equals 3. And so that means that a is 10 to the third. But I said that a equaled the log of x. So that means that the log of x equals 10 to the third, which is 1,000. And so our base is 10, so x equals 10 to the 1,000. And so that would be what your x value would be. Okay? Sorry for that. Looking at one more, we have x to the log x, to the square root of log x equals 10 to the 8. So what we are going to do, we have a variable in our exponent on the left-hand side. So we're going to take the log of both sides. So we're going to say the log of x to the square root of log x equals the log of 10 to the 8. And then we're going to move our exponents to the front. So I have the square root of the log x times the log of x equals 8 times the log of 10. You just move your exponents to the front. Now on the right hand side, 8 log of 10, the log of 10 is just a 1, so you're left with 8. On the right hand side, we have the square root of x basically times x, which is x to the 1/2 times x. This exponent is a 1. When you're multiplying, you would just add your exponent. So 1/2 plus 1 is a 3/2. So this becomes log of x to the 3/2. Okay? So you just combine your exponents there. And then to get rid of that 3/2, we can raise both sides to the 2/3. And so if you raise both sides to the 2/3, you're going to end up with just log of x. 8 to the 2/3 is 4. And so our base is 10 here. So x equals 10 to the 4th, which is 10,000. And so that would be your answer there. So for the most part, those are the same types of problems that you'll have. They may change that 8 to another number. They may change this 3 here to another number. They usually are going to leave those as just square roots. And then same thing with those. Usually those are going to be 2's. But they could change that 2 here to another number and leave this squared as it is. But you're going to work them all pretty much the same way as what we did in this lesson. Okay, so hopefully if you need to, you can go back and re-watch part of it for one of them if you get confused on your homework for it. But on your homework tonight, you do get to omit 7 and 25, so make sure to do the rest of them for your homework, and then we can go over any questions you have tomorrow.